Okay, everybody. I wanted to make another video having to do with drainage patterns, and we looked at drainage patterns in the class notes. Again, those diagrams maybe aren't the best, and I'll try to make it a little better. So one of the drainage patterns that we talked about in the video was this idea of a dendritic pattern, and dendrite or dendrology means tree-like. Dendritic means tree-like. And if we think about the branches of a tree or tree roots, well, a dendritic drainage pattern is going to look something like a tree-like structure. And we would see this on land where we have hills and mountains and the water flows down the valleys into maybe one main channel and then goes somewhere else. This is what's called a dendritic drainage pattern. Another drainage pattern type we talked about was the trellis pattern. This one, to be honest, I always have a little bit of a hard time explaining. I think that this diagram is at least better than the class notes. And this really has to do with the geology, the type of rocks that are under the ground. You could ignore anticline and syncline. That's more of college level kind of stuff. But here we have different types of rocks. They're sedimentary. They've been folded, though. And because they've been folded, we have different layers of rocks at the surface. It's been folded and then eroded. And one of the concepts that we talked about earlier in the unit was this idea of differential weathering. Some rocks are harder and some rocks are softer. And in this case, it looks to me like the gray rock is probably supposed to be shale, and the yellowish rock probably limestone. And what's happening is the shale is weathering more easily, but the limestone is more resistant. And because this is a fold that's been weathered and eroded, we have these ridges of the harder resistant rock, that it says right there, resistant rock. So we have these ridges of the harder rock, and then in between the ridges, we have the shale that was weathered out more easily. And we end up with this, at the surface, this ridge pattern with some breaks and gaps in between. And when it rains or precipitates or snow melts, the water is going to flow between the ridges, or in between those ridges, and then sometimes across them where there are these gaps. And we end up with a drainage pattern that has this shape, and we call this a trellis pattern. And this is really formed by the type of rocks that are underground and this type of situation where we have folding and differential weathering. I was having a little trouble explaining that in the notes. We also talked about a radial pattern. Radial means circular. Imagine radius, like in math. Or a bicycle wheel would be a radial type structure. And we often see this with mountains. Here we have a volcano. It could easily be a tall mountain too. And when the water or rain falls, it's going to drain out and away from the peak of the mountain, or in this case the volcano, in all directions. That's a radial drainage pattern. One of the ones that I have a hard time explaining, I tried to find a better picture, but I just couldn't. We have an annular pattern. This is a circular pattern. The concept is similar to the trellis pattern. We have more resistant rock in a circular pattern, and then less resistant rock in between. We end up with these kind of ridges of circles. We have this circular pattern. This has to do with the geology that's underground, the types of rocks that are underground. Again, differential weathering. We see this in geologic features called domes, basically like a rounded hill. Sometimes we get this kind of feature with volcanoes too. And we see a drainage pattern that looks something like this. So sometimes this can be a little confusing, but basically as far as Regents questions go, and you could be asked some questions like this on the quiz at the end of the week, well, let's just look at some sample questions. Here we have what's called a block diagram. It's trying to show the land, and here we see the different rock types and the ridges and the softer rock in between those ridges. So softer rock has been eroded away, weathered and eroded away, and the harder rock is left behind. Again, that's the concept of differential weathering. So we have these steeper ridges where it's more resistant. And then we have these low spots where the rock is less resistant and has been weathered away. And when the rain falls over a landform like this, the question is basically asking you to match the drainage pattern we would see with the rock pattern. And on one like this, well, we have this kind of circular pattern, right? So the only one that shows a circular pattern like this with the differential weathering, the ridges, would be a choice 2. Right? If we look at this one, here we have that trellis pattern. And it's asking which underlying bedrock structure most likely produces stream drainage pattern. Well, it would have to be number 4, right? Number 4, again, we get this trellis pattern when we have rocks that have been folded. The more resistant rocks take longer to weather, so they end up forming ridges. And the softer rock in between weathers and erodes away and makes little valleys, and we end up with this trellis pattern. With these kind of problems, you have to think about the way water would flow. And if rain is falling over the entire thing, well, where would the water go? You know, remember, water always flows downhill. Water is always going to take the path of least resistance. Let's look at a couple more. Here it says, which map best represents the stream drainage pattern that is formed because the stream flows over a nearly level landscape region covered by loose sands and silts, and not because of the underlying bedrock below? Well, that would be a stream, a regular river. We've got meanders, bends, you know, it would be one like number 4. You know, and here we have our regular erosional, depositional pattern that we talked about. Erosion on the outside of the curve, deposition on the inside, and so on. We talked about that a bunch of times. Number 4, it says the maps represent 3 different stream drainage patterns. We have radial, annular, and trellis. Which statement is generally true of these drainage patterns? Well, this is just process of elimination. All are controlled by underlying bedrock structure. That sounds pretty good, but it's important to look at all the choices. All are in the old age stage of stream development. That doesn't really make much sense. Number 3, all are located in semi-arid regions. Not necessarily. Number 4, all are located in areas where deposition is greater than erosion. Again, not necessarily true. Really, number 1 is the only one that makes sense. The bedrock underneath is controlling the way that the water flows in these examples. And number 5, I think this is the last one. The maps represent 4 different stream drainage patterns. Which factor most likely caused the differences in these patterns? Same type of question. Bedrock underneath. You know, again, it goes back to differential weathering. The harder, more resistant rock takes longer to weather. It takes longer to erode and forms ridges, and the water is going to flow between those ridges. And we talked about annular and radial and trellis and so on. This is all due to bedrock structure, not human activities, not directly associated with climate, and not directly associated with time. You know, you might be able to make an argument for time or climate, but bedrock structure is the most obvious and best answer, which is always what you're looking for. Okay. So anyway, that's it for drainage patterns, and I'll have more videos posted next week about glaciers.